So let's talk about changes that we have observed in the cryosphere. And the cryosphere is the ice system on Earth. We're talking about sea ice, ice sheets, ice caps, glaciers. What are the changes? And you already know that there was a significant warming occurring, and you would expect that this has an impact on the ice coverage. Okay. So let's start with the Arctic sea ice. Okay, the Arctic Ocean is an ocean that supports the formation of sea ice because the surface water is cold and it stays at the surface because it has a low salinity, which comes from the meltwater. So here the water can supercool and form ice. Okay? There are regions where you have a permanent existence of ice, where ice is always there. Okay? And there are regions where on a seasonal basis the ice melts or the ice forms again. So there is a seasonal cycle. So if you can imagine that, is that the ice here, so one image shown here is that the ice is coverage is increasing and then shrinking, increasing and shrinking, increasing and shrinking. Yeah, from in a seasonal cycle. Okay. However, we observe a significant decrease in the ice coverage in the Arctic Ocean. Again, and here's shown here in one example. Okay. So what's shown here is the median extent derived from data between 1981 and 2010 from satellite data is this yellow curve. This yellow curve shows the extent, and the white areas here is the observed minimum extent for the summer of 2016. And you can see the blue is ice-free. Okay? You can see that there are significant areas which are ice-free, in particular here in the area connected to the North Pacific through the Bering Strait. Okay, significantly less sea ice in this area. You can look at the time series, and this is shown above my head. A time series from 1985 to 2015. So we're talking about 30 years of data. And the top curve shows you the total sea ice extent, and it stayed relatively the same until 2000, and then from there on, significant decrease. Some fluctuations, significant decrease. In terms of ice, you can also look at the different age of the ice. You know, the ice that's just formed in the first year is called first-year ice, and then older ice is called second-year ice, third-year ice, fourth-year ice, or 5 years plus ice. And you can look at the changes of different age classes, and you see that the oldest ice is disappearing in this area. Okay, it's the old ice disappearing, older than 5 years. Okay, and remember, it's a stack plot. A stack plot, you can see that the change comes from the older ice. This is what drives the change here that you can see in the total extent. Okay, what you also can do is you can look at the length of the melt season. Okay, which is shown in this graph. Okay, the y-axis is a date axis, which starts at the top May and then goes through June, July, August, September, and October, and we're talking about Northern Hemisphere summer period. Okay, and you can mark the start of the melt season and the end of the melt season, and we're talking about temperatures dropping below zero or raising above 0 degrees temperature. Okay. So now what you can see here, if you look at that, is just that the start of the melt season is earlier, and the length of the melt season increases. So the end is also later. And that's what happens in the Arctic Ocean as a response to global warming. Okay. So what I want to show you here in this simulation is the same thing, but giving you a better feeling for seasonal changes and changes from one year to the next. So what's shown here is a polar plot which shows the extent of the sea ice as a function of the months of a year, moving around in a circle. Okay, but if the ice extent decreases, you move closer to the center. The center corresponds to 0. If the extent increases, you move outward. You move over to a larger areal extent. And these circles correspond, the outer circle corresponds to 15 million square kilometers. The middle one corresponds to 10 million square kilometers. The inner circle corresponds to 5 million square kilometers. And in the center you would have 0. Okay, so what you would expect over the 1 year is an increase over the winter months and the decrease over the summer months. But let's see what happens over the years. Okay, you can see these cycles repeat. And it stay relatively the same, but now after 2000, you see these dramatic changes happening, okay, over the summer and by the end of the summer. So let's see whether the end of the simulation still works. We're getting there. You can also flip around this and have a look at the changes in the minimum and maximum ice extent, and you can see that there is, starting from the past, you can see that the minimum extent decreases, as does the maximum ice extent. Okay, so you get changes both ways, not only the minimum but also the maximum. There's less ice is formed during winter time. So I should have mentioned that the melting or the formation of sea ice actually does not affect the sea level. There is no impact on the sea level. And you can test that at home. You have a nice drink, put an ice cube in there, but don't drink it. Just mark the level of the fluid, wait until the ice has all melted, and you notice that the level is exactly the same. So, sea ice, ice that is formed in the ocean, and you melt it, there's no change. Okay. All right, we come to the Greenland ice sheet loss, and I'll just do that very quickly. You know, the observations of that the ice sheet on Greenland is losing mass over time, and there's a time series shown here. Okay, you can see seasonal cycles as well, but over time there is a rapid loss. Okay, so melting of the entire Greenland ice sheet would raise the global sea level by 7.2 meters. This is, you can work out. You know, if you know the thickness and the extent, you know, you can work out that. But we still think that this melting is not rapid. You know, we think it will take thousands of years. Okay, but we are not certain about it. Okay, we are not certain because recently we observed a relatively rapid melting anomalies, and this is shown here on the left side. So this is Greenland. It's the Greenland ice shelf, and it shows you melt anomalies in red. And this is for the year 2021, and you can see areas where have relatively large amounts of melt, regions that melted. Okay. And it's shown here as a time series over the year 2021 compared to previous years. We had actually 3 severe heat waves in that area that resulted in relatively high melt rates. Okay, and this is just recent research. We don't know how long it takes or whether there can be accelerated melt of these ice sheets. Okay, so that's the story about the Greenland ice sheet. But I have another interesting story for you, which is about the Antarctic ice. Okay, we're also talking more about the sea ice. Okay, but also the so-called ice shelves. These are the ice shelves that reach into the ocean. They are in contact with the seawater. That's a very fascinating story because you get some very unexpected results. Okay. This is now the time series of Antarctic sea ice. This blue line. Okay. From 1980 to 2022. Okay. And you can see variations, okay, and they can be linked to modes of interannual climate variability. Okay, you can do that, but then surprisingly, the ice extent actually increased until 2015. And then there was a sudden drop. Okay, there was a large area melted, and we can actually have a look at just in a second where this happened. And then since then there was an increase again. Okay, so very confusing message. And if you actually look at the global warming map that I showed you before, you also don't get a clear warming signal throughout the Southern Ocean, polar regions. Okay. So this area behaves a little bit different. It has the Southern Ocean around it, which is one reason. So it's in terms of the global warming, you don't get the direct effect of the global warming signature that we have. You don't get that in the Antarctic sea ice. I only added this red arrow just to illustrate that we don't know what happens. We don't know what happens, whether it's, that we expect that there will be a downward trend in this area on longer times, but we don't know how long it will take. So, looking at different times which are shown here, okay, you look at the ice coverage that's first shown here on the left, and then on the next graph, you show the areas which experienced the most loss until 2015. And you can see here the West Antarctic shelf lost large amounts of ice in this particular area. Okay, but in more recent years, we have an increase of the ice coverage, and there's a more dramatic ice loss in other areas. Okay, so we still don't fully understand the Antarctic sea ice response to the global warming signature and what are the precise causes of these variations. So Antarctic sea ice changes are more difficult to understand. Forgot to tell you that if all Antarctic ice melted, it would raise the average sea level by about 70 meters worldwide. And that's why the focus is on Antarctic sea ice as well, in the context of sea level rise. So for completeness, I want to just briefly talk about glaciers. Okay, glaciers are melting as a direct consequence of the global warming. And you can see that if you compare images. So this one is the McCall Glacier in Alaska, 1951 and 2003. And you can also, there are many studies around with, which document the melting of glaciers. If you melted all glaciers and small ice caps, the global sea level would rise by between 35 and 50 centimeters. Okay, that's the glaciers We can also look at permafrost, okay? Changes in the permafrost. Okay? And we're looking at the northern hemisphere, okay? We're looking here we are over the North Pole and we look at the permafrost, okay? Which is illustrated in different colors, in white, and then you have the transition which goes more into the blue areas. Okay, and let's see whether this movie works. Okay, showing you changes of permafrost regions, and permafrost is the critical issue because of the release of methane, which is stored in these areas. Okay, so the permafrost in the northern hemisphere is thawing. Okay, we're going here now into 2016, 2017, and you can see the changes. Okay, this is to 2017. We are at the end of this movie. All right, study questions. Okay, so what key changes due to human activity have been observed in the oceans? How has the cryosphere changed in the past 20 to 30 years? What is pH? And what do we mean by ocean acidification? What's the overall role of the ocean in terms of global heat and carbon budgets in this era of the Anthropocene? What are the main reasons of global sea level rise? So why are the sea levels rising? So thank you very much.